About the difference between a numerical expression and an algebraic expression and how we kind of evaluate each of them differently. When we're talking numerical expression, it means there are only numbers. So this one over here on the left is a numerical expression. To simplify them, we follow the order of operations and get our answer. So order of operations here would tell me that I have to do parentheses first. So 1 minus negative 3 is 4. Then I do exponents, 4 cubed, which I think is 64. And then we would have to, of course, multiply. I don't have a calculator, so maybe you can calculate that right now for me. And then you finally add that to negative 8 and you get your final answer there. That's simplification, just a numerical expression. We're not trying to solve anything, we're just simplifying things as much as we can. This one on the right is called an algebraic expression because it contains some algebraic things like variables. All right, so if we're going to evaluate an algebraic expression, we have to know what x is. Notice it doesn't say solve for x. That's an equation. We're doing that later. We just plug in our x equals negative 3, and we simplify as much as we possibly can. So negative bases always go in parentheses, so make sure you have negative 3 in parentheses. And then we simplify. So exponents first. We can multiply these two right here. So we get a negative 36 plus a negative 18 minus 5. And again, you can combine those now and get that final answer. So those are kind of what we're doing all of today. You just have to keep in mind what you're doing. Remember, you are not solving anything, you're just simplifying or evaluating. All right. Some special vocabulary that you'll want to make sure you are aware of are these things. Okay. Terms are separated by a positive or negative sign. So terms are parts of a sum. Like terms have to be first a term, and then they have the same variable parts. So an x and a y, not like terms. An x and an x squared are not like terms. They would have to be an x and an x. There's a constant term. That just means there's no variable attached to it, so just your plain old numbers. And a coefficient is the number that is in front of a variable. Very important that we're all speaking the same language when we talk about these things for the year. So really good to know these terms if you don't already know them. Okay, an exponent is actually just the power, and the base is that bigger number. So on the previous page we had, something like a negative 3 squared. The exponent is the 2, and the base is the negative 3. Okay, there's your reminder, friendly reminder over here about order of operations. PEMDAS is probably something you've seen before, but that reminds you what order to do your operations in. Good to point out, multiplication and division are from left to right, as are addition and subtraction. That's a really common mistake people make. Always do those from left to right, not multiplication then division. Word problems, super fun for a few people and really annoying for most. So let's say you have this word problem. You're going to buy your friends a CD or a DVD as a gift. CDs have a cost of $13, DVDs $18, and we're supposed to write an expression and then evaluate if 4 people get CDs. So something that's helpful to think about is a verbal mathematical model. It's optional, you never have to write it down or anything, but it's helpful to get you to think of what that equation might look like rather than just jumping straight to the equation. So if I'm going to buy some CDs and DVDs, I would have to take the price per CD and multiply it by the number of CDs, right? And then I would have to add that to the price for DVDs times the number of DVDs. So that's kind of what I'm thinking about as I'm building this mathematical model or the expression I'm looking for. Okay. One really good thing is we need to choose a variable. And I would give you the hint that your expression is in terms of CDs only. So CDs is going to be what's represented by our variable. So our price per CD was up here, $13. Okay, $13 up there. So 13 times number of CDs was going to be our variable, so I'm going to use X. Price per DVD given to us up there, 18. And number of DVDs. That's kind of tricky because we can't use another variable. We only want to use X. We don't want two variables. That makes life really difficult. So how do we figure that out? We're missing something there. So if the number of CDs is N or X, whatever, how many DVDs did we buy if, remember, we're buying for 10 people? Did you say 10 minus N? If you did, you are absolutely correct. So this would be 10 minus X, since I used X up there for some reason. Okay, so there's my mathematical expression. I could simplify things a little bit. If I distribute, so 13x plus distributive property here, 180 minus 18x. So it looks like I simplify it to 180x minus, or 180, sorry, minus 5x. And that's what we would call our algebraic model for that box. Then there's this little part squeaked in here. When n is equal to 4, how much will we be paying? So n is 4. That was my x variable that I used. So 180 minus 5 times 4. Well, 5 times 4 is 20. 180 minus 20. $160 to buy your friends these gifts. All right. These verbal models that we started with tend to make word problems a little bit easier if you're one of the people that doesn't really love them so much. All right, here's a couple just so you can check to make sure that you understand what's going on. So I would pause the video and then I'll come back with all of the answers and you can see how you did. Okay, so we would have -6. We're going to plug in that -6 and square it, minus 9. So that's a 36 minus 9. And 36 minus 9 should be 27. On the other side, we have a couple distributive properties to do. So we'd have 3x plus 12 minus 6 minus 2x, because we're distributing a -2. And then combine your like terms. 3x minus 2x is x. 14 minus 6 is 8. So my answer there would be 8. That should do it for today's lesson. Let me know if you have any questions. Good luck.